Okay, we're being asked to find the first derivative of a function that's really a secant function, but it's working on the square root of 2 raised to cosecant 7x plus 5x to the fourth. So this is a pretty complicated problem. It has multiple things going on. And so I'm going to sort of approach this in layers. This is kind of how I do it with my class when I try and teach this, is rather than looking at the whole thing, I'm going to look at pieces, and then we'll go ahead and put it back together again. So I'm going to start off with the derivative of secant. And we'll just call this secant blah. We're not going to worry about the fact that we have all these numbers. We're just worried about the fact that this is 2 raised to the cosecant 7x plus 5x4. We're not really focusing on that. We're really focusing all of our thought really on this derivative piece here for right now. Okay, so when I go to take that derivative, the first derivative of a secant is really secant blob. So a derivative of secant, we'll call it x, is really secant x tangent x. So that's what we're going to get out of this. I'm going to get secant of the square root 2 raised to the cosecant 7x plus 5x to the fourth. There's our first piece. And the second piece is going to be tangent of that whole blob. So 2 cosecant 7x plus 5x to the fourth. And there's our first layer, so to speak, of this problem. Just looking at the secant gives me secant tangent of that function. Okay, now we're going to go inside. We're going to look deeper into this. So I'm going to look here at what the derivative of that piece, because remember, this is sort of nested within one another. So we've got to do a derivative with inside. So I'm going to go ahead and look at what would I get if I looked at the first derivative of that inside piece. So of the square root 2 cosecant 7x plus 5x to the fourth. So now I'm really looking at sort of the derivative of this square root function. That's really what I'm focusing on here, is really this derivative of the square root function. Okay, so what I get here is really the derivative then of 2 cosecant 7x plus 5x to the fourth raised to the 1/2. There's our square root piece. And how do I do that? Well, we've got multiple layers to this. So the 1/2 is going to move to the front. I'm going to be left with this inside piece here. So the 2 cosecant 7x plus 5x to the fourth. Only now when I subtract 1, it's going to be raised to the negative 1/2. Okay, and now I've got to look sort of the fact that this is a exponential power. So I've got this rule basically says, yes, I'm taking the square root piece, but I'm also now going to give me my original function back. So 2 cosecant 7x plus 5x to the fourth. And I'm also going to get the natural log of the base, or of the 2. So that's this next layer. That's this whole next layer right here. And that's our second piece of our final solution. The last piece we're going to look at to this is I'm going to look at what happens when I take the derivative of this portion, the actual power. So the power of this is cosecant 7x plus 5x to the fourth. And so individually looking at this, the derivative here would give me negative 7 cosecant 7x cotangent of 7x. Okay, so the rule for cosecant derivative of that would be cosecant cotangent, and then the 7x portion of that, this piece here, is what produces that 7 that's going in front. And now the derivative of this piece, which would be 20x to the third. So there's our third portion to this answer. So we have 3 layers to this. It's very complicated in terms of what we're doing, but we have to look at each piece, bite-sized problem here. So when I go back to look at this original problem, when I take the derivative of kx and I take the derivative of that original function that they gave us, which was secant of the square root 2 raised to cosecant 7x plus 5x to the fourth. And we put all these pieces, all these layers we've just talked about, what we come out with is the first derivative of k, that first derivative, is going to be, and we're going to rearrange this a little bit here. So I've got 1/2 of 2 raised to the cosecant 7x plus 5x to the fourth raised to the negative 1/2 times the original function of 2 cosecant 7x plus 5x to the fourth natural log of 2, and that's still all, this is all multiplied, times secant of the square root of 2 raised to the cosecant 7x plus 5x to the fourth times, so this is all multiplied together as one big answer here, tangent of 2 raised to the cosecant 7x plus 5x to the fourth, still multiplied, so times negative 7 cosecant 7x cotangent 7x plus 20x to the third. So all of this is our final solution, all multiplied together as one final first derivative. Hope that helps. Good luck.